So as just mentioned, we'll be talking about the MITRE ATT&CK framework and how it relates to the cloud matrix. Some of the topics we'll be discussing today will be an overview of what the attack matrix is, what and how TTPs work with the attack matrix. We'll go over an overview of the cloud matrix in detail. We'll discuss how teams could work with the cloud matrix, and we'll also mention and do an overview of some business considerations that you may want to think about when working with the cloud matrix, and an overall wrap-up. So what is the attack matrix? The attack framework, also known as adversarial tactics, techniques, and common knowledge, is a knowledge base around adversarial emulation. It bases its intelligence off of open source intelligence that mirror real-world adversary tactics, techniques, and procedures. The framework is mainly used for building threat models, applying methodologies related to adversary behavior, defining your threat hunt procedures, and communicating cyber threat intelligence via your various data sources. So how is the framework used to date? It's effective in 4 categories: detection and threat hunting, threat intelligence, adversary emulation, assessment and engineering. And when we discuss detection, we mean the framework allows you to fine-tune your current analytics. A number of organizations already have detection capabilities in some form or fashion. The framework allows you to assess, refine, and fine-tune. Analysis of the framework and ingestion of the data allows you to apply new analytics. And from those, determine and assert the quality of the data you're working with for those analytics. When it comes to threat intelligence, it allows you to take your various data feeds related to threat actors, threat groups, and different business concerns, and communicate in a common language that can be communicated to your SOC team, your business executives, and your managers. When it comes to adversary emulation, it allows you to organize your red team initiatives and prioritize various scenarios in relation to the business organization. When it comes to assessment and engineering, it allows you to influence how and what data is collected, determine the quality of your ingestion pipeline, and whether or not it is effective to date for your organization, with an avenue of assessing your current tool base for working with that data and determining redundancy and effectiveness and requirements for management and refinement of your current tooling in place. Now let's discuss TTPs, tactics, techniques, and procedures. They are the who, what, when, where, why for an adversary or an attacker. So when we discuss tactics, we are looking at attacker motivations, why they want to attack the organization. And if we look at an example from a Windows environment, an attacker may want to gain persistence in your network. So that is their tactic for persistence. Technique describes the method that an attacker applies to execute their tactic. So in the topic of persistence, we're looking at an attacker that will leverage the Windows registry to maintain said persistence. And when we look at procedures, these are the specific implementations of those techniques. These are the low-level detailed commands that may be executed by adversaries or have been recorded to be executed by adversaries in the past. So in this scenario, it might be leveraging CMD to modify the regedit with the regedit tool to modify the system registry. One thing to keep in mind with procedures is They change rapidly as attackers' techniques evolve, and they are prone to constant refinement and evolution.
That's a really good point, Jeff. So for those that are kind of new and those that are experienced, like I think it's really obvious, procedures are going to be constantly evolving, whether it's influenced by threat intelligence or by just security research, or as you start to refine your controls. So just kind of put this question out there. As you look to apply attack, or if you already are, or just kind of speculating as which way you would go, there's a few different sources for these procedures. One would just be open sources that are published and there's available. There are some commercial tools out there. So there's maybe you plan to just really rely on your vendor that's providing that commercial tool to kind of update those. Maybe you have the ability to develop or customize open sources or create new ones in your in-house team. So you want to build your in-house team to kind of really own and maintain this. Or perhaps you're looking for partnership with an information security vendor or a consultant or someone to develop procedures that are really specific to your organization's landscape. So what controls you have in place, what technologies you're using, what platforms. So give it a think and answer one of those. Again, this is just kind of conversational, so whatever you think is best. All right, so let's see those results. All right. Yeah, so, pulling from open sources, there's certain strengths there. It allows you to move fast. Okay, that's great.
Okay, so moving on. We'll jump a little bit on the timeline and evolution of the attack framework. So in 2015 was the public release of the Windows Enterprise Matrix. This started off with 140 techniques. Based on the popularity and adoption of the Windows Enterprise Matrix, the Mac and Linux Matrix followed suit. Mac OS came out originally with 89 techniques, 29 exclusive to the Matrix, i.e. those techniques wouldn't be seen inside of the Windows Matrix. Linux came out with 80 techniques, 12 were exclusive, and based on, again, the popularity and community support for this initiative, MITRE also introduced the mobile matrix. In 2019, November 2019, MITRE introduced the cloud matrix, coming out with 36 techniques. And following along suit, and currently in refinement, is the ICS, or Industrial Control Matrix, in early 2020. One thing to note is the philosophy of the attack matrix and the way objects and adversary threat behavior are categorized has been adopted by other organizations. So in early 2020, Microsoft also released their version of the attack matrix associated with Kubernetes. So now that we've touched briefly on the history and the basics of the attack matrix, we'll talk about the cloud matrix specifically. So the cloud matrix is 100% community supported initiatives. This is different from, let's say, the Windows, Linux, Mac OS initiatives, where the matrix was built from threat intelligence data obtained through open source means by MITRE, where the cloud matrix was the involvement of the community to recommend that this matrix be created and supply the initial TTPs for said matrix. Additionally, as stated previously, the matrix is fairly new and bound to evolve potentially exponentially due to the community involvement. For reference, the Windows techniques came out, the number of techniques for the Windows Enterprise Matrix was initially 140. It's now evolved to more than 200 techniques. The domains currently covered by the Cloud Matrix is AWS, or Amazon Web Services, GCP or Google Cloud Platform, Microsoft Azure, Microsoft Azure Active Directory, Office 365, and various SaaS platforms, aka software as a service. The tactics associated with the cloud matrix range from 6 to 10 based on the domain. So there would be a different number of tactics for AWS versus an Office 365 scenario. Techniques currently to this date are 43. So when we dive into the techniques associated with the cloud matrix, we can see some trend analysis where 70% of those techniques are reflected in other matrices, in this case, the Windows matrix. So what does that mean for you as an organization, as a security team? It most likely means that even though this is a new matrix, you are probably already applying or thinking about the techniques that would be associated, the TTPs associated with the cloud matrix in some form or fashion in other domains, in this case, your Windows domain, with 30% being unique techniques to the cloud environment. So what does that mean? Well, an example of a unique technique that you wouldn't assess initially in a Windows environment or build detections for would be cloud instance metadata abuse. For a quick explanation of cloud instance metadata would be that cloud providers allow a way to assign roles, RBAC capabilities to various cloud resources. That may be traditional VMs, that might be Lambda functions or functions as a service, and those are tied around capabilities and what they deem the Cloud Instance Metadata Service API, which allows you to make calls to the management layer of your cloud environment. So when we look at those unique techniques, we can see the breakdown of where they lie in the cloud matrix. We have initial strong support for techniques in the defense evasion tactic area, followed by split between credential access, discovery, and movement at 50%, with room to grow in exfiltration, persistence, and collection, which sits at 7% of the amount of techniques unique to the cloud matrix. And we can tell there's various room for these techniques to grow, expand, be refined, have additional procedures tied to them, because cloud technology changes rapidly and the number of resources available grow at an alarming rate. So an example that we've noticed is what we don't currently see in the matrix would be either a technique or sub-technique or procedure around persistence through automation templates, which is a very important factor of cloud environments that might be reflected from AWS in CloudFormation templates, or in Azure, for example, in Azure resource templates. So overall, when we look at the maturity of the matrix, we see that there's a higher overlap in existing matrices, which is good for an organization that's already started to think about the attack framework, as this wouldn't be starting from scratch for them. We see that the matrix is fairly new, but has large community support, with a number of organizations, teams, individuals, researchers lending a hand to refine the framework, add opinions, supply additional data sets and data sources, even though the initial technique number is fairly smaller compared to Windows. It has high potential for growing leaps and bounds. And from a security company's perspective, we see that there's a potential for the cloud matrix or maybe individual framework to grow into various other cloud technologies, such as DevOps tooling and containers, which we see Microsoft adopting in some form or fashion. Now we'll talk about working with a case study that provides us a way to work with the cloud matrix. So as an organization, your threat intelligence may come in various forms. You may already have what is known as a threat feed that already has various level of IOCs being ingested in your different platforms. You may also receive information from media reports that might be a top-down ingestion where a business manager, business executive wants to know how the organization sits in relation to a popular attack that's been publicized. And you as an organization may be proactive and build internal scenarios quarterly or when new technology comes into place. So if we take that into consideration, we'll look at a scenario where you've received a media report about a financial institution being breached. And they have a court order available publicly. You read the court order, which states that an attack group or potentially an individual has managed to exfiltrate a large set of customer data from a cloud environment. Even though most of the information is redacted in the legal report, you can surmise a few things. You can surmise that the attacker compromised some edge-facing application, and that data to the private bucket and data was exfiltrated from a private bucket or data storage. So looking into how you can map this to your attack matrix, you can make some assumptions that are applicable to your organization to build a scenario with some of the missing information. So first off, we have initial access, categorized as T1190, which is exploiting public-facing applications in the cloud matrix. That's based off of the information received, so you can have high fidelity that this technique should be considered. Based on the end information of data being exfiltrated from a private bucket, you can assume that there was privilege escalation involved and assign that to T1078, usage of a valid account.
Looks like Jeff, your screen dropped there. Jeff might be having some connectivity issues. We'll just give him a second to rejoin.
Sorry about that. Let me reshare the screen.
Thanks.
Okay. Hopefully we're all good.
Yep, back on track. Thanks, Jeff.
Some assumptions about the scenario. Okay, great. So based on the use of valid accounts, that would be the only method currently to date that you would be able to access a privately configured bucket. So moving along to the other tactics, you can now surmise that credential access played a part, and specifically the technique of T1522, which is Cloud Instance Metadata API usage. This would be information that you would get from the initial legal report or additional feeds that attempted to analyze or hypothesize the detailed actions in that legal report. Moving alongside, you can also confidently assume that a discovery tactic was performed, especially T1526, cloud service discovery, in which case an attacker gains credentials and they may perform various API calls to gain a sense of who they are and what they can do. And based on the legal report and the actor's actions, you can confidently assert that collection was performed in the form of T1530, which is data from a cloud storage object. Now, when we talk about exfiltration impact here, even though in the detailed report or in scenarios applicable to your organization, you may have exfiltration capabilities of using a VPN, using a C2 channel, and various other forms, that is not directly that can't directly be aligned in the current attack cloud matrix exclusively, but if you expand the matrix to include other domains, you can leverage that to assign that technique. And for impact, which is fairly new to the attack framework, you can consider that not applicable because impact from MITRE is around compromising the integrity of the data or the capabilities of you and availability of your resources. In this case, the attacker did not perform that. They simply exfiltrated information. So you have that data set and you want to now visualize it and perform and develop a scenario and a plan around it. So we are using Attack MITRE's Navigator to visualize the information we've just parsed from an intelligence feed. We've highlighted the areas that we see are applicable to mapping out the scenario. And we can move on to associating this and working with a third-party penetration red team company like Security Compass or an internal red team. So the red team, either internal or third party, takes your requirements for the scenario to perform and they work with it and communicate it in a way that stays in line with the attack MITRE framework and an ingestible and evolving pattern. So in this case, Security Compass is asked to red team your organization with the goal of gaining access to an S3 bucket or a data storage bucket that you deem to hold potential critical information. So the company performs the assessment. They are looking at your public-facing applications. They are performing traditional web attacks to gain a foothold. They are initially unsuccessful, and they look at other means or methods that an attacker or adversary with the identified qualities may also perform. They successfully find static credentials in a public version repository. This allows them to then abuse initial access of a valid account. They leverage this to maintain persistence in some form or fashion with this valid account as they have the access token and it hasn't been rotated. This is also considered a privileged escalation technique because they're going from no access to access under a trusted user. They also leverage this for defense evasion because as they're working through it, the access key is not getting rotated and they are not getting booted off or limited or noticing any guardrails around their movement through your cloud infrastructure. They then associate the valid account to be able to access an instance in your environment, potentially a private VPC. And with that, they notice that there is a role attached to that instance, which allows them to leverage the metadata API. With the metadata API, they repeat the process and perform cloud service discovery. In this case, it's fairly loud. They are making every read API call in the cloud environment to determine which one returns a 200 response with some data, some useful data. And through the assessment, even though they're able to gain foothold and access to various data, they are not able to access the data storage in question or in scope specifically. Now, traditionally, you'd receive a penetration test report that would have this information detailed and standing as a silo. But in this case, the red team or third party also communicates this through modifying the navigator framework to discern what was successful execution and what was failed execution. So you as an organization and your security team take that back, and you can now start organizing and prioritizing the outcomes from the assessment. So for detection, you can ask yourself, how well did we observe the red team or third-party red team's actions? Well, you can assign a score gradient. In this case, it's arbitrary 0 to 100, but you can adjust it to what you see fit. And you notice that, yes, we did notice a lot of increased web traffic to our edge-facing applications, and we were able to detect attacks being applied, some from traditional loss top 10, and others novel to the framework or web application stack of your applications. So you can give yourself a fairly positive score that your detections are strong in your edge-facing applications, and you can have some positive feedback for your AppSec team in terms of the initial configurations and deployment strategy for your applications. You can also then acknowledge that your team was not able to successfully discover or detect abuse of a valid credential that was publicly available. This allows you to start building out strategies on A, how would we go about that? And B, where do we want to start our detection capabilities for potential credentials for potentially exposed credentials?
So
next, go ahead.
No, I'll let you finish your thought. But I do have a quick poll after this because I think this is really important.
All right, sounds good. Now, looking further into the report and feedback from your red team, you can discern that your detection capabilities sit at around a 50-point grade for usage of valid accounts. This is a standard reality because valid account usage and building detection around it may prove to be a difficult task around multiple false positives or false negatives. This allows you to present this as a risk acceptance scenario and a way to effectively state why and why not can some detections be put in place. Looking further into the report, you see that the red team has stated that they were able to abuse the metadata service API, and they were able to abuse leveraging credentials and files. You reflect that upon your current detection capabilities and data ingestion, and you notice that, yes, we do not actively ingest data that would relate specifically to metadata abuse. So now you have an action item for strategizing, okay, we need to ingest more data into our scenes and our platforms. And one of the priorities would be what could be an effective way of ingesting said metadata API information. Continuing along with the report, you can confidently state that when the red team asked, yep, we performed loud cloud service discovery. And you can affirm on your side that, yes, we had a number of alerts determining successive API calls that returned access denied. So you can apply that to a score gradient stating that, yes, our initial initiative to solve this problem is proving fruitful. And even though the red team was unsuccessful with gaining access to cloud storage object, you may evaluate internally that yes, our controls in place for the cloud storage object are good, but we are either unsure or we've identified areas where we actually were not doing as much verbose logging as we would like for what we deem as sensitive or mission critical data.
So just want to pause now for a second, because I think that this view really kind of speaks to a challenge that has always been there. And that's, once a security program is operational, how do you connect the tactical level, like the findings, the importance of them, and make it still actionable at a tactical level, but still communicate it to a more senior level so it can align to strategy, and making that clear communication so you can get top-down support from leadership to actually, get funding or whatever support you may need to make impactful changes. So, at a glance, I'd say that this accomplishes that really, really well. You can clearly see it's got a nice color coding of where your problems are, but at a tactical level, you can see exactly where they are and you can start applying those. So just a quick poll to kind of challenge that assumption. Like, do you see like this visual element of attack helpful to both steer communication to all levels, from tactical people that are going to be, our engineers and architects, up to leadership? So just a quick poll, give us your thoughts on how this fits into your org, or how it may fit into your org if you were to leverage this MITRE ATT&CK framework. Okay, so let's see those results. If there's any thoughts on that? Right. So, no, it doesn't translate well into our vulnerability management processes. That's actually surprising. So that was really good to see. That doesn't really apply to everybody. Sometimes, if you're looking at some legacy management systems, it's like, no, everything must have a CVSS score. It has to fit nicely into Archer. And it becomes very difficult to kind of make those types of, tactical findings reach up to senior level communication. But it looks like the majority of people here see the value across all levels of involvement in the information security program. Great. Pass it back over to you, Jeff.
All right, thank you, Josh. So looking further, as an internal security team, you have two responsibilities in the MITRE framework. One would be your detection capabilities, and also how your mitigations are currently performing. So again, looking back at the information that the red team or offensive security team has provided, you can take that and start asserting, like, how well are we doing for mitigations? How hard are we making this for adversaries and attackers? So you can infer and determine that based on the current attacks leveraged by the offensive team, you have a pretty good mitigation platform for your edge-facing applications. You're applying defense in depth. You have multiple services enforcing your mandate of secure programming and secure application development. You can also continue to refine it. So you may have it in the 90 percentile of, yep, we're pretty strong with our mitigations and the procedures we're applying. And you can now start bringing up the topic of, maybe we can go further. How well are we doing with least access to the application, to the public-facing application? You may even go further and state, like, okay, our edge-facing controls are pretty good. How would we do post-compromise? And you may restart the discussion with the offensive team to state, that's great that you guys performed that black box assessment. Let's refine it a bit more, where you have some sort of foothold, and we'll work from there to see if our mitigations still apply. So you have positive feedback for the team and still additional action items for how we can continuously do better. For your mitigations, you can now accept that the abuse of valid accounts may not reach the 90 percentile, because locking down or limiting the capabilities of valid accounts may prove to be counter business intuitive. So you can take that 50 percentile in your mitigations for valid account usage. Maybe you're performing least access, but the access still has ways to potentially abuse the system, and combine that with your detection capabilities to say, okay, we can start limiting, prioritizing how we can mitigate valid account usage because we may face too much pushback, and start refining further how we can start building more detection capabilities. And working hand in hand with that, you can take potentially two limited scores and raise both of them up by using them in tandem. And continuing to look at the report feedback in relation to mitigations, you can state that, okay, we need an action plan around how we can limit the the usage or abuse of metadata API abuse. And that might come in various forms based on the popularity of the attack vector through service-side request forgery. A number of cloud providers have offered the option of using version 2 of that metadata service, where there are proxy-like controls that will not allow requests from originating from a source, a non-local IP source. So you may add that as a consideration for your mitigations. You may also have internal security controls in mind for working with the metadata service. But now you at least have a way to prioritize, well, should we continue focusing all our efforts on our public-facing applications? Should we focus on valid accounts, or should we focus it on cloud instance metadata? You now have an additional set of data to assist you in defining that. And looking at your mitigations for your data cloud storage objects, you can give your team a pat on the back saying, like, our defined mitigations and controls are proving effective. So with that, you can now have a life cycle of continuous development around your detection and mitigation capabilities, because you can take this, have a point in time analysis, and continue to grow it from various assessments and scenarios where you build upon, okay, we did well here, we have some pain points, we're going to refine those pain points, and then we want those pain points reevaluated. And you can demonstrate effort over the quarters with this initiative. This proves valuable because you may have initial support for certain capabilities, tooling, detection strategies, maybe in Q1. And in Q4, you may be asked, well, how did all this play out? And with a framework like this and working with your offensive teams to continuously reevaluate and work alongside a consistent output, you can demonstrate over time how your security program has evolved. And with that, we'll look into some business considerations for the cloud matrix. So when we look at cost considerations, even though the matrix itself is open source, there's no additional cost considerations. But the framework will drive how you budget and prioritize your efforts. This might be in, okay, we've received initial output and feedback, and we may or may not need to have additional resources fine-tuning our current data ingestion sources or the alerts that we build from those data ingestion sources. You may identify a tooling gap where we have no visibility on the data we need to look at to properly discern how well we're doing in this specific tactic. You may also consider it a use for how you procure tooling that sits in the assessment and engineering category, where you may decide that, okay, we have certain products we need to consider. How well do they do? How well do they relate to the matrix? And do we have too much redundancy amongst the tools that we have? This may then drive efforts to refine what you already have, or determine how important are the non-redundant points that these tools cover. So now we can look at some of the business benefits for adoption, which some of it we touched on previously. You now have a common language for communicating red team activities. You have something top down to express, yes, we're communicating with our offensive security team like this. They're reciprocating this information. We can take this information, align that to our various threat data feeds, and we have an applicable output for our security operations center. And then we have a way to demonstrate progress to management. The matrix assists in potentially reducing risk by allowing you to measure, assess, and come to terms with what your team can and can't do for various scenarios, and more importantly, ways that the team can improve, and methods to allow for your offensive team to continuously address and provide feedback on the capabilities, the mitigations and detections being applied to your security, to the organization. This also allows you to visualize this in some form or fashion. In this case, we've demonstrated it through Attack Navigator. And a method for taking data that may seemingly not be as actionable, maybe from media feeds, maybe from incomplete threat reports, and still finding value in them to have an action plan around. So with that, we can now see the ecosystem that the MITRE framework sits in. And from detection and threat hunting, this allows you to start creating playbooks, identifying execution gaps. Threat intelligence, you now have a potential language or method to parse this information. From adversary emulation, we can see that this is a platform for scenario creation, scenario execution. And for assessments and engineering, you now have a way to perform tooling refinement and identifying implementation.
So just reading through some of the questions, can working with attack be automated in some way? So I'll put that question over to the panelists, talking about automation of attack.
Yeah, that's a very good question, Paul, here. So there are currently multiple solutions available to assist with automation around the MITRE ATT&CK framework. Some of these are free open source tools. One of the most common and probably well-known ones, or one of the older ones at least, would be Red Canary's Atomic Red Team. There are many similar tools that do sort of the same thing. And there are also now several commercial options available. Some of the advantage to open source solutions are that they're essentially freely available without any upfront costs to the organization. They also tend to be highly flexible and extensible. You have access to the source code, so you can modify that if you want to add test cases. The key being, MITRE is a framework, right? Or the MITRE ATT&CK framework is a framework. It's not the end all and be all. So you can add your own scenarios, your own TTPs. Some of the drawbacks of the open source tooling are that they essentially tend to facilitate execution of the test cases for TTPs themselves. They don't do much else, right? They tend to be sort of script based. They don't have a user friendly GUI. They won't produce, fancy reports and that sort of thing. So those are where the commercial solutions tend to shine. Some of the other things that, so we've actually looked at some commercial solutions. Some of the other things that they have that the open source solutions don't have are, again, just sort of more comprehensive test cases. Sometimes they'll have different threat intel sources. They'll add in additional things like testing of email controls and WAF testing and other, I guess, quote unquote, advanced features. And again, they produce more management friendly reports, I guess we'll say. If you're looking for a solution to automate testing or use of the MITRE ATT&CK framework, some considerations would be number one, extensibility, right? So as I mentioned, with the open source tooling, you can just add whatever test cases you want. A lot of the commercial products that we've looked at don't actually allow for you to create custom test cases. So this will essentially limit your testing ability to only what's available in the tool. That can make it difficult to reconcile results from third-party testing, whether that's like an external contractor that comes in and does a red or purple team test, or your internal red team. If they are executing the same tactics and techniques, but with only slight variations on the procedures. So maybe they're using the same command, but just a slightly different syntax on the command line, right? If your detections are brittle, you may detect the TTP from the automated tool, but not from the manual testing. And then you have to sort of reconcile these differences. If the tool is extensible and allows you to add that other test case, well, then you can have that in your tool and you can tune your detection and then still have everything sort of in one place. But if you can't do that, then you're stuck with these two disparate sets of results that you sort of have to track and reconcile over time as you keep testing. Another thing to consider would be output formatting and risk ratings. So if your security program uses a specific risk rating system, so just as an example, CVSS scoring, you want to make sure that any tools you implement use similar standards. So some of the tools that we looked at will use proprietary algorithms. So they'll take pieces of CVSS and other scoring systems, and they'll do some magic on it and provide their own score from 0 to 100 for each TTP, right? And if that's the case and you want to make sense of those numbers, you may have to map that back to something that makes sense to your organization. Another thing to consider would be integrations. So if you're looking at a tool, does it integrate directly with your SIM to automatically determine if a TTP was successfully detected, right? Some of them will actually use the APIs available from a SIM, and it'll execute the test case and look for an alert that fires. And if it sees the alert, it says, okay, we know that we detected this and we alerted on this. So you want to make sure you want to know if the tool you're looking at will do that, or if that's going to be a manual process over and above. There are other considerations as well, of course, but those are some of the bigger ones.
Great, thanks, Paul. There's another question here, just real quick. I think I can answer this, but so the question here is, if we're already using Prisma Cloud or Dome 9, these types of tools, do we need to even look at Cloud Matrix? And the simple answer there is, yeah, certainly. They meet different needs. Where something like Prisma is going to be more of a continuous compliance to make sure your cloud configuration specifics are maintained in kind of alignment to your standards and policies. You're still going to be using the MITRE ATT&CK framework to evaluate your controls end to end to prevent, detect, and respond. But some of the work that goes into some of that side could feed back into Prisma or Dome 9. So if you identify misconfiguration, you may want to tune your other tooling to make sure that that's not systemic across your org, and to protect against any kind of regression kind of issues. So I got another one here. Do cloud native tools support MITRE ATT&CK?
Yep. So in short answer, yes, in some form or fashion. For example, AWS Security Hub allows you to categorize some of your data feeds with TTP categorization. So what that means is when Security Hub presents various alerts and findings, you can associate or tag them with MITRE related TTPs. And so that's what we're currently seeing. So it's evolving, and cloud providers seem to be on board with leveraging or displaying usage of the matrix in some form or fashion.
Great.